Hi everyone. Today we will talk about metering valve. So metering valve, as from the name, you would have get an idea. It's to control the flow. It's a valve. Valve is always used to control the flow. Now, if we just talk about any type of valve, it could mean a valve used to on off the flow. It has only two states. You can switch it on and whatever the full flow may come out of the valve, and if you switch it off the flow will stop. Now in metering valve, and there are other types of valve like the tap you used in your home just does not on off the flow, but it also give a variation in the flow. So by rotating the tap you can um, change the amount of flow that is coming out of the tap. Now that is not precise. Like, now if you want what do you mean by precision here? Like if I want, suppose 8 kg per hour or 100 kg per hour or 8 kg per minute of flow from a tap, I can get an approximate of 8 kg, but not exactly 8 kg. The tolerance will be too high. So that is what we mean by precision. We want as low tolerance as possible. So the metering valves are used here where we need a very precise flow. Like if I want 8 kg per hour of flow, then the tolerance should not be really wide, right? It could be 8.1 kg or 7.9. There are multiple types of metering valve. So we will go through each type one by one and we'll see what is the difference there. First, there is needle valve. So in needle valve, as from the name, you may get some idea what is the needle valve. So in each valve, there is a hole, and you have to plug in the hole with a type of plunger. When plunger fully block the hole, you don't get any flow. When it start getting away from the hole, the flow will increase, and up to a certain height, up to a certain lift from the hole, certain distance from the hole, you will get a maximum flow. And if going beyond, there will not be any further increase in the flow. This is the basic design of every type of metering, or in general, every type of valve. There is a hole, and you are going to plug in that hole. Now, depending on the plunger or depending on the hole, you get a variety of valves. Especially in case of metering valve, in case of needle metering valve, plunger is in the shape of needle, right? If you can imagine, if you can picturize the needle, there is a sharp edge of the needle, which is not just uh, a localized edge, but it has shape. The pointy edge has a conical shape. So that is the needle valve. By controlling the taper of that edge of that conic shape, you can um, control how the flow will vary when you rotate the tap. Here is you can manually rotate the tap to lift the needle away from the hole, right? Or you can use a motor. In the motor, you can use a stepper motor, which rotate in stepwise motion. I can give you a basic idea of stepper motor. Now we know to complete one full rotation, the motor has to rotate by 360 degrees. That is basic geometry. So if a motor rotate by 18 degree, right, it need to complete 20 that 18 degree steps to complete one 360-degree revolution. And suppose it lift 1 mm in 360 degree. So if you rotate it in 18-degree step, it will have a lift um, lift rise is equal to 1 by 20 because there are 20 steps. Right? So 1 by 20, it's around 0.05 mm. So that's how you can precisely control the flow by just rotating the handle, or if in case of stepper motor, you can apply some voltage, right? And you can apply voltage pulses in sequence. So this is the basic idea behind needle valve. Then you have ball valve. The ball valve is again it is plugging the hole. Now, in case of lifting the plunger away from the hole, two holes provided in the hole. So in the off condition, the whole axis of the ball and the axis of the hole provided in the wall will be at 90 degree. And if you start rotating the handle manually or with the help of stepper motor and start decreasing 90 degree, the both the hole will start aligning with each other. So initially the alignment will be small, so there will be a small opening. So fluid start coming out of the valve, and with gradual decrease in the angle of the axis angle from 90 degree to 0 degree, the flow will increase accordingly. So that's how you control flow in case of ball metering valve. Then you have um, globe metering valve. So globe metering valve, basically there is a disc type plug. The end of the plunger is in the shape of plug. It basically fill the whole of the valve. By rating the handle, or with manually or electronically, you can lift the plug away from the hole. So the name globe came from the shape of the outer shape of the valve. It's in the shape of a spherical shape. So these are the main categories of metering valve. So that's it, guys, for today. Come back tomorrow with another interesting topic. Thanks for watching.